3. Okay, so this is f of x, and f of x is the derivative of capital F of x. So capital F of x would be the function that's the area, and it changes according to the area under this. So determine which gives a lower value, R4 or L4, of the change of f from 1 to 3. Okay, so now we're just supposed to determine which one's going to give the lower value. So R would use the right side, and the right side would be, and see, if we're going to split this into 4 places, that'd be 1, 2, 3, 4. And if we use the right side, that would make this first one too tall. That would make this one too tall because this function is increasing. So right would be too much. The left, if we use the left side, would be underneath. The left side would be underneath. The left side would be less. So since the f of x increases, the L4 will yield a smaller estimate. Okay, and now if we calculate L4, the width of the interval would be, let's see, that would be a half. And then we'd want to use the height on the left side. That would be, oh, so that looks like about 3/4 or 0.75, if you will. Plus the left side of this one would be 2 1/4. Oopsie, that's 1 1/2, excuse me. 1.5 plus, well, let's call it 2.5. Left side here is 4.2-ish. No, 4.3 plus 4.3. These are estimates, so it's all right to make approximation. So that's 5.3. So 1 1/2 plus 2 1/2 is 4. 8 plus 5 is 13.6. 1/2 times 13.6 is going to be 6 1/2, 6.8, I believe. And we don't know what this is, so we can't give the units. But that's the change in capital F over that interval. Number 4. The thickness of ice on a roof on a given day is given by this function. So the thickness is what capital F gives us. So little f is the change in it. It's the derivative of capital F. So it's the change in the thickness. So little f's units is going to be inches per t hour. And capital F will be just the inches. So this says, and t is hours after midnight. So 2 hours after midnight, there's a 1/2 inch. This says at 7 hours after midnight, so that would be 7 a.m., there's 4 inches at 7 a.m. And at 5 inches at 9 a.m. Now this is the integral, which is going to give us the area under this, which is going to give us the change in the capital F. So from 2 hours after midnight to 3.5 hours, so that's from 2 a.m. to 3:30 a.m., the ice increased by 0.75 inches. And between 4 a.m. and 7 a.m., the ice increased 1.5 inches increase. So now let's get to the problems. A, what did it do? How much did it increase? Because this is the change, the area. How much did it increase from 7 to 9? Well, at 9, it was 5 inches. At 7, it was 4 inches. So it must have gone up 1 inch. And they want me to explain what's going on here. So that's what that's why I'm writing all this stuff. Now we have to figure out what this means. Wants to know how much ice at 4 a.m. Well, let's see. From 4 to 7, it went up by 1.5 inches. At 7, it was 4 inches. So if 4 inches after went up 1.5 inches, it must have been 2.5 inches. This says, how much was there at 3:30? Well, at 2, there was a 0.5 inch. And from 2 to 3:30, it went up 0.75 inches. So 1/2 plus 0.75, that's 1.25 inches. 1.25 inches at 3:30. Now the tricky one. So this is how much it increases from 4 to 9. Let's see. From 4, we figured out at 4 it was 2.5 inches. At 9, it's 5 inches. So the increase is 2.5 inches. But 9 minus 4, that's 9 a.m. minus 4. That's in the noun of hours, which is 5 hours. So this is a rate again. And since we're doing the total change in the thickness over the total time that passed, we're getting the average. And so this is 2.5 over 5 is 1/2. 1/2 inch of ice per hour is the average increase per hour of ice between 4 a.m. and 9 a.m. That's what they wanted on that one. Okay. 5, you need to know the difference between an odd function and an even function. So odd functions when it's like x to an odd power, so it's one where it does something down here and does the mirror image up there. It's a 180-degree rotation. So the area under this odd function between -2 and 5 is 8. Well, that's a long way. We don't have it. Let's get a little more. 0 to 2. it's 3. So somehow there's an area of 3. Let's say it looks something like this. And so this is plus 3. Since it's an odd function, back here would be minus 3. So if I'm going from minus 2 to 5, and I get a total of 8, well, minus 3 plus 3 is 0. I'd have to get 8 more in here. So I have to have plus 8 there, which means back here would have to be minus 8 if it's an odd function because it matches. Okay, so how much is there between 0 and 5? From 0 to 5, we got plus 3 plus 8 is plus 11. How much between 2 and negative 5? 2 to negative, oh, that's backwards. So everything gets switched. So if I'm going from 2 to negative 5, that would be negative 3 plus 8. That would be a total of plus 8. How much from negative 5 to plus 5? Well, on an odd function, from negative 5 to plus 5, these are going to cancel those. So that's going to be 0. Okay? Number 6. Okay, we got the derivative of the integral. Those are basically going to cancel, except this is a function of t, and this one's of x, and we're going to put x's. So whatever this function's antiderivative is, which we don't really know, I'll just call it capital F, we're going to have to put in 5x squared minus f of 2. And then we have to take the derivative with respect to x. Well, the derivative of the function will be back to this, but with this plugged inside. So this would be the square root of 5x squared cubed plus 4. But wait a minute. If I take the derivative of this, the derivative of f is this, but then I have to take the derivative of the inside of that we're putting in here, the 5x squared, which is 10x. Now the derivative of this constant is 0, and so there's my answer. Or the other way to think about it, we're putting in this in place of the t's into this times the derivative of this. Okay, 7. We're integrating this, and this is all separate problems. We could integrate each part separately. The integral of x to the minus 2, we can use the power rule. Add 1 to minus 2 would be x to the minus 1 divided by minus 1. This is the square root of 2 times x to the 1/2, or we can do 2x to the 1/2, but that's what this is. So if I use the power rule on this, I'm going to get plus square root of 2, add 1 to 1/2, and we get x to the 3/2 over 3/2. Then we have a minus 2 in the integral of sine. See, the derivative of cosine is negative sine. So this would be negative cosine x. And then each one of these would have a plus c, but I could just do 1 plus c at the end. And so this is negative 1 over x. This would be plus 2 square roots of 2 over 3 x to the 3/2 minus would be plus 2 cosine x. This is not subtract. This is negative 2 times this plus c. This one. Well, we can't do each part separately because this is division. But the subtraction is in the numerator, so I can divide both parts by x to the 3rd. So this would become the integral of 5, subtracting 2 from 1/2 is x to the minus 3 halves dx, and then we'd have minus, and 2 from 3 is 1, integral of x dx. Using the power rule and pulling the 5 out, we'd have 5. X adding 1 to minus 3 halves is minus 1 half over minus 1 half, minus the integral of x is x squared over 2 plus c. We could call this the 2, if I multiply by negative 2, that cancels that, and that makes it negative 10. X to the minus 1 half is square root of x in the denominator. The negative puts it down, and half is square root, minus x squared over 2 plus c. C. All right. Looks like the derivative of this would produce a 2x, and the x's would cancel. So I'm going to do a u sub on this one. I'm going to let u equal x squared minus 1. du would be 2x dx. So dx would be du over 2x. So this would become the integral of 3x over u, and dx becomes du over 2x. These are multiplied, so the x's can cancel, and the 3 halves can come out, and so I'd have 3 halves, the integral of 1 over u du, which is ln absolute value of u plus c, which should be 3 halves ln of x squared minus 1. Okay, and 7D is one that we're going to learn about later, so don't do that one. Next one, 8. Okay, when we got absolute value, we need to think about the graph. X squared minus 4, that's a parabola that's been moved up 1, it moved down 4. 1, 2, 3, 4, so by negative 2 and by plus 2, it would be hitting the axis. Now, if we're integrating from 0 to 5, this first area would be negative, and so we'd have to do the negative of the integral from 0 to 2 of x squared minus 4, to negative to make this area positive, and then to do the rest of this to the 5, I do plus the integral from 2 to 5 of x squared minus 4 dx. And the integral of x squared minus 4 is x to the 3rd over 3 minus 4x. We're doing the minus of this, evaluating all of this from 0 to 2, plus, and we've got the same thing here, only this time there's no minus, so this would be x to the 3rd over 3 minus 4x, evaluated from 2 to 5. So if we put in 0, or 2 first, that's 8 over 3 plus 8. Then we put in the 0 and we would get 0. So we got this minus 0 plus, we put the 5 in here and we've got 125 over 3 minus 20 minus, and we put the 2 into this, and we're going to get 8 over 3 minus 8. So we've got 125 over 3, that's 41 2/3, minus 20, minus 2 1/3, plus 8, and we got minus 2 1/3 plus 8. So we have minus 2, minus 4, minus 20, minus 24, and 16 and 41. 16 plus 41 is 57, minus 24, that would be 33. And then we got a minus 1/3, plus 2/3, minus 1/3. So those thirds are going to cancel out. So I'm going to have plus 33, I think. If I didn't make arithmetic error in there, could always check that on the calculator. Type this in and integrate from 0 to 2 and 2 to 5, or type the whole thing in with the absolute value. But I think that's what that'll be. Now in this one, we're going to do a u sub, and there's a lot of possibilities for the u sub. It could be the 4x squared, it could be the x squared, it could be e to this, but I think if I let it be this, the derivative of that would be 3x squared. The x squareds would cancel on this, so I'm going to let u be simply the 8 minus x to the third. So du would be negative 3x squared dx. So du over negative 3x squared would be dx. So this becomes the integral with new limits. Let's see, what would be the new limits? If x was 1, we'd have 8 minus 1, which is 7. And if x was 2, that would be 8 minus 8, which is 0. And we'd have 4x squared e to the u, and dx is du over 3x squared with a negative. So I can pull out the negative 4/3, and I'd have, and the x squareds would cancel, and I'd have to integrate e to the u du, which is just e to the u, and I'm evaluating that from 7 to 0. So this would be negative 4/3, e to the 0 is 1, so I put 0 in there, I get 1, plus, because it's minus a minus, so it would be plus a negative 4/3 plus 4/3 e to the 7th, or 4/3 times 1 minus e to 1 minus 1 plus e to the 7th, or e to the 7th plus minus 1. Anyway, that should be the answer. Okay, this one. Well, I could let u be cosine, but I'd still have this mess in the denominator. I'm thinking I want to let u be the sine. The derivative would cancel cosine, but if I let it be sine plus 1, I get rid of the plus 1, because the derivative would still be Derivative sign is cosine. So d theta would be du over cosine theta. This is still going to cancel the cosine theta. So I'm going to have the integral. I'm changing my u. So I can change the limits or I can come back to them, but I'll go ahead and change them. Sine of 0 is 0 plus 1 is 1. And the sine of pi over 2 is 1. 1 plus 1 is 2. Cosine theta over the square root of u. And dx becomes, Well, this should have been d theta. That's a misprint. So d theta becomes du over cosine theta. These cancel. So this is just u to the minus 1/2 because it's in the denominator. So if I integrate that, that becomes u to the 1/2 divided by 1/2 evaluated from 1 to 2. So this would be the square root of 2, because 1/2 is the square root of 2. And this comes up as a 2 if I multiply numerator and denominator by 2. So I get 2 square root of 2 minus, and if I put 1 in there, I get 2 square root of 1 is 1. And this one I did in class. The wiser choice for the u is that mess, not all of the mess, not the x, just ln of x squared plus 2. So du would be, derivative of ln is 1 over whatever ln is of, times the derivative of the inside, which is 2x. So if I solve for dx, I'd have to multiply both sides by x squared plus 2 and divide both sides by 2x. So this becomes the integral. If I'm changing my limits, this would be 0 in here is 0 squared plus 2 is just 2 ln of 2. And at the top, I'm putting 2. That's 4 plus 2 is 6, ln 6. And I would have x u over, let's see, if I factor 2 out of this, I get 2 times x squared plus 2. And then my dx is x squared plus 2 over 2x du. And this cancels. The x's cancel. And so I got 2 times 2, which is a 4 in the denominator. So I got 1/4, and my pen's dying. 1/4 integral from ln2 to ln6 of u du, which is 1/4 u squared over 2 evaluated from ln2 to ln6, which equals 1/8 ln6 squared minus 1/8 ln2. squared. And we got that to be approximately 0.34 in class. But you can leave it like this. Okay? And finally, in the very first sections, we talked about differential equations. If dy equals this, and we integrate this, then we find out that y would be, integrate this would be 4t to the third over 3 plus t squared plus c. And this says if t was 0, we're supposed to get 5. Supposed to get 5 if we put in 0. So that would be 0, that would be 0. So c would be 5. And so I can write the final equation. So they said determine y. It'd be 4t cubed over 3 plus t squared plus 5. And one thing that I didn't talk about in the last section is when you integrate something like this. The only function that you can take the derivative of, and it still looks like the same function, except maybe by a constant, is if y looked like something like e to the kx. The derivative of this would be k e to the kx. It looks the same as the function and the derivative look the same except for a constant. So this is telling us the constant has to be 1.4. So y has to be e to the 1.4x. And if we put in 0, e to the 0 is 1, but we're supposed to have 5, so there must be a 5 that's times this. And there can be a number a here times this, and it would still have an a in here. And so that's the number we got there. And so this is the function. Okay?